Dr. Sean.
Yep.
Okay, cool.
Yep.
So give me a little bit of the overview that Sean talked to you about, just to get your bearings. The star there, that's headquarters. So that's the main building. I don't know if you guys went. Where we are is this winter manure and tillage area, and then we're going to go to this other field where Laura's working on. So there's a little bit of information on the station itself. So the one I'm going to be talking to you about is the bottom one, which is this multi-scale investigation of winter runoff. So this is a collaborative project between myself and several other researchers at UW-Madison. The lead of the project is KG, and he's a faculty member in Biosystems Engineering. And we are also working with Peter Vadas from the Dairy Forest Research, so that's the USDA. So we have UW and Federal Lab also working on this. Laura Ward-Good, have you talked to them about Snap Plus yet?
They have Snap Plus, yeah.
So Laura Ward-Good is the keeper of Snap Plus, and she's the brains behind Snap Plus, and then she has the programmers behind it. And a lot of the faculty assist with some of the information going into Snap Plus. So we have the science board, and this is one of the examples that we'll talk about. And then myself, and the project actually is trying to look at the impact of winter applications of manure. A lot of farmers don't have a lot of storage, and there's a need to apply manure in the winter, so we're trying to look at that and trying to get more information. So the project itself has 2 different tillages, or basically surface roughness that you can see here. We actually just did the tillage last week, I believe. So this would be a conventional till, so it's just a little bit fall, and then we'll come with a finish in the spring. System. And then we also got that in over, so that would be our smooth surface. We want to have that difference in the surface. And then we have to manure their operation here, which their milk opening anywhere between 400 and 500 dairies, so it's fairly long. So I don't know, Sean talk about that. Every field here in the station, they have to have a nutrient management plan. So imagine the person who's in charge of this keep there. You got to keep up nutrient management. So she has to know what I'm doing here because she has to know for the
Yeah.
So talk about somebody busy. Yep. So we have 2 applications. So December, before the ground freezes, that's one of the application times, and then the other one is in January. We try to do it in January. They comply with the regulations to meet that but with frozen ground. So the idea is, what are the conditions of the soil, and what is that doing to runoff? And then you can see here some of the equipment we have. If you look at the plots themselves, we have them firmed up. By 50 feet long, so it's contained here. And then everything obviously is going to go down slope, and we can walk down there and look. So the berm is to try to keep everything in here in place. And then we have this collection system. Piece of board that is staked to the ground, right? It forms a V, so everything gets collected to the central point here. Just hooked up to PVC. Actually, if you look at this closely, it's actually a toilet flange. So we got to get innovative with some of the stuff we do. The screen there is to keep carriers from going in because they love going in here. So then the runoff will come through this pipe, and then we'll come into this box here. As you can see, we have 18 plots, and so we have a bunch of these boxes, and so this is for this plot. I'm sorry. This one is for this other plot. So the water would come here, fill up this bucket. You can see then that there's this crown, and that works as a weir, if you will, like in a dam. So water will fill that up. Water will get to this top level, and then it would actually, some of the water is actually going to spill out, and then we just collect from one of those into the second bucket. So that's actually, that crown has 24 slots. So we're collecting 1/24. So what that allows us is that increases the capacity, the amount of runoff event that we can actually monitor, right? If we had all of that going back into this one, that diminishes the amount. And so this is basically a split sample that we do, and then it goes into the second bucket, If that guy fills up, which this past season only happened maybe twice, then you get some into this one. If that one fills up, everything goes out. But that gives us a pretty good capacity for storing a runoff event. I think we're close to like 3 inches of runoff that we could collect here on each block in an event, and we haven't exceeded that. So the trick with this is that you want to have it really level. So you see that triangle on the bottom has screws on the bottom. That's to level it. You see the level here. So, and you know, in the winter things, you know, shrink and swell, and so you got to do some tweaks and what have not. The other thing you'll notice down there, then all the water that comes out, then it will come out, and then it will be collected down there, and there's a corrugated drainage pipe, and it drains out, and that's all you feel. See the flag? Actually, this one drains. You see that flag? That's the outflow of that one. The lower plots, on the southern portion of the field, they'll drain into the field. So there's challenges with this. I mean, you can see that it's really neat. We can collect all the runoff, but some other things we have to get creative. You know, this is a flange from like a roof to keep critters again coming out. You can see we actually have snap crabs. These are custom made. They were made by the University of Tennessee. We already had them laying around. They were using all their projects. So research is kind of fun. I like it because of the instrumentation, you know, things like that. What you need to measure and how to do it. It's very important. So the other thing too is that, so this would give us, okay, you have the treatments, this is the response, this is what we saw. But we're also interested in seeing why we saw what we're seeing, right? The observations. So you will see we have full-blown weather station there. And what that allows us, so I have a PhD student working on this project. Her name is Melanie Stock. And she actually came up with doing some of these schemes of what I'm talking about now. So with that one, we're actually trying to figure out the energy budget. You know, you guys are from Wisconsin, so you know snow, the weather conditions that we have really dictate when we get melt, right? You know, those kind of things. So having a handle on how much energy is coming or going from the soil and from that snowpack, it's critical to then be able to predict when we'll see some runoff from that under these conditions, right? And then if you think about the manure application, when are we seeing that coming? We also have a control where we're going to apply manure on the treatment, so we can kind of then compare that and see when is this happening. On top of that, when the ground freezes, a lot of people think that it just seals up and there's no infiltration going on. There's still infiltration happening. You still have some, it's diminished compared to the summer time or spring, but you're still seeing some infiltration. So we're also getting a handle on the water budget of the soil profile, but to be able to do that, we also have to have an idea on the frozen conditions of that soil. So we have, maybe we can see them on the note, plots a little bit easier. So we have thermocouples, which are devices to measure the temperature of the soil at different depths. We also have water content sensors in these soil plots. All the plots have at least water content in one measurement, and then we have one replication. I'll talk about that here in a second. One set of plots that we have what we call the heavy instrumentation, and we have several depths of moisture measurement, several depths of temperature measurement, and additional measurements. And that we also have a matrix potential sensor to measure the matrix potential of the soil. I don't know if you've talked about that in class, but the soil, I don't know if you know that, the soil had the way it holds water, holds it under suction, retention is what we call it, it's a suction. And so this device allows us to measure that. When the soil freezes, that tension, that suction increases tremendously. A little bit of tip, if you've never thought, you know, what makes that ice stick to your windshield? There's actually a very, very thin layer between the ice and the glass. And there's actually the same thing that's happening in the soil. That's actually a suction capillary in adhesive and cohesive actions of that water. So that's what holds that ice in the windshield. Same thing's happening in the soil.
Sure.
Okay? So it goes tremendously, so we're measuring that. You might see that there's a little pipe sticking out of the ground there, kind of spray painted. So we also have frost tubes. So we have this, essentially it's a vinyl tubing you can buy at Menards. That's where we bought it. And we fill it up with water and a dye. And so if you look at ice blocks, you see sometimes they have cloudiness, and that cloudiness is kind of concentrated, right?
Yeah.
So what happens is when water freezes, the solids tend to go into the free water, and so it kind of gets a squeeze, right? And then it freezes completely. That's why you see that cloudiness. So you can use that better manage that type of phenomena, where you can have water in this final part of
Francisco's duties as the extension specialist is to try to help predict, for farmers when is all the Connor's got a really nice system on their dairy farm. They're doing cover crops behind silage and doing a really good job of things. We're challenged in Wisconsin, of course, because we have winter and you still have to deal with manure every day, right?
Yep.
And so if you the trouble is, well, it's going to be even more so when in January there's typically a January thaw. Along with that thaw, there's a runoff event that puts all this fresh manure smack dab into our waterways, which is, of course, a major issue. And for a long time, we've tried to help predict that for farmers, and this research will actually make those predictions.
So the whole idea with this is that eventually, it's called a multi-scale project because we start actually looking at. So one of the things that happens is you have to start looking at interaction with the So part of the project is actually looking at pollution factors and seeing that partitioning of the water and the snow. Then we go to another scale, which is a funnel, and we actually collect snow, and then we layer things out. So we put, let's say, layer snow, manure, and then snow on top of it. We have a layer snow and manure, and then we put it in a water and see how it flushes out. So we actually separate it. And that allows us to see that interaction. If you apply manure and it's snowed, is it releasing differently than if you just spray it to the bare ground and apply it and figure those things out. And then the field scale, we also have a rainfall simulation scale, but then the field scale. Eventually what we want is actually have this help us, like Randy was talking about, better inform our models and the knowledge so we can improve the snap loss, right?